How's it, grade 10? So we are still busy with financial maths, and what we're going to be going on to today is population growth from slides 34 to 36 from the PowerPoint financial maths. Okay, so you're probably asking, why is population growth part of financial maths? It's because it fits with the formula. Now, what we're going to do is, I'm just going to read out a few things and I'll explain which one it is, okay? So populations in nature generally increase every year by a certain percent, as you know, okay? If you have a look at the human population, the population gets more and more and more every year. The increase at the end of the year depends on the population size at the beginning of the year and not on the initial population size at the beginning of the observation, or the principal amount. Now, the increase is therefore compound, okay? It's not a linear or a simple. And you've noticed that, like with, for example, a virus, okay? A virus starts off the population very small, and then it just increases, okay? Very similar to the human population. We've had a very low human population, the beginning of history, and now it's just shot up, okay? So we're looking at an exponential growth or a compound growth. So for population growth, we are going to be using the compound formula. Okay, and you've learned that in the previous lesson. So if we look at example 1, I'm just going to read it out first. It says, in 2010, the population of Mexico was approximately 110.6 million people, and the population growth rate was 1.4% per annum. PA stands for per annum. What will the population of Mexico be in 2060? So A is equal to, P is equal to, I is equal to, and N is equal to. And we know we're going to be using A is equal to P, 1 plus I to the power of N. Okay, so we know what our initial population size was. It was 110.6. And I just want to make a note here, guys. This is million. Okay, so I'm not going to write out this with 6 zeros afterwards. I'd rather just use something that's simple like that. They're going to say that our growth rate is 1.4%. So 1.4 over 100. I'll just make a note of that was 1.4%. And then they said that this population size was measured in 2010. And they want to know what is the population size in 2060. So how do we get whatever this is? We're going to say 2060 minus 2010. And you can see there we will get 50. Okay, and this is the one that we don't know. What is our accumulated amount after 50 years? I'm just going to plug our values into the formula. So A is equal to 110.6, 1 plus 1.4 over 100 to the power of 50. Okay, so if I use my calculator now, we get 110.6, 1 plus 1.4 over 100 to the power of 50. Okay, so we get an answer of 221.6. I'm just rounding it off to 1 decimal place. So that means, therefore, we will have 221.6 million people in 2060 in Mexico. Okay, if we look at example 2, example 2 is saying a bacterium grows at a rate of 50% every 3 hours. Okay, so let's just make a note of that. It grows 50% every 3 hours. Okay, it goes on to say, if there are 200 bacteria on day 1, calculate the number of bacteria after 12 hours. Okay, so I'm going to use this with the total time. So it's telling us if, okay, first of all, A is equal to P is equal to I is equal to, and N is equal to. So we know what our principle is. We started off with 200 bacteria. Now, this is going to be a little bit tricky, working this stuff out here. So I know that this is going to be 50 over 100. That's our interest. Okay, now this is the tricky bit here. Okay, because they want to know how much how much bacteria there is after 12 hours. We know that this thing is increasing every 3 hours. So what I want to know is my time period here. So I'm going to take the 12 and I'm going to divide it by 3. And you can see we get 4. So our time period is 4 cycles. So it is going to increase 50% 4 times. Okay. And this is what we don't know. So now I'm going to plug that into our formula. So that was just the tricky bit over there. So A is equal to P, 1 plus I to the power of N. So we get here A is equal to 200, 1 plus 50 over 100 to the power of 4. And I can work this out now on the calculator. So we've got 200, 1 plus 50 over 100 to the power of 4. Okay, so because we're getting a 0.5 here, we can't have half a bacteria. So what I'm going to do is I'm just going to round it down. So therefore, we have 1,012 bacteria. After 12 hours. Now, why didn't I round it up? Well, I can't round it up because I can't just make half of a bacteria just appear from nothing. Okay, so I'd rather get rid of that half of a bacteria and just make it a full number like that. Okay, grade 10s. So what I would like you to do for me is exercise 12.6, please. Thank you.